Today's video is going to be about how to simplify rational expressions. So your note page looks like this, and there are 5 steps to simplifying rational expressions. So all we're going to do is just make sure we can work our way through the steps. So the first step is to write the problem as a numerator over a denominator, so turn it into a fraction. As you can see, for example 1, it's not written that way, so we're going to have to fix that. Step 2, we're going to write all the terms in descending order. So if you look right here on the top part, you can see that the exponents are out of order, so we're just going to fix it so they are in order. After everything's in order, we're going to look at step 3, where we factor the top and the bottom. So we're going to break the top and the bottom to things that are multiplied together. After we factor, and here we have all the different ways we could factor. We'll come to that in a little bit. After that, we're going to reduce what's in common. So we're going to say, oh, on the top you multiply by 5, and on the bottom you multiply by 5. Well, those 5's cancel. And then at the very end, we have our simplified form, and we are done. So that's kind of the process, and we're just going to go ahead and walk through each of those steps on the examples and make sure that we know exactly what to do for these problems. So I can't write tiny, so I'm going to go ahead and write the first example on a new screen. So here was the first example, and if you look at step 1, it says to write the problem as a numerator over a denominator. So my numerator is negative 6x plus x to the third. My denominator is x squared plus x. Step 2 says to rewrite the problem so that everything is in descending order. So I'm going to rewrite this so that the x to the third comes first, and the negative 6x squared can go second. The bottom of the fraction was actually totally fine, so we're good with that. Now step 3 says to do the factored form of the problem, and if the very first part's negative, we'll factor out a -1 as a GCF. Step 2 is to just factor out any GCFs you see. We can also use the difference of squares or the diamond method. If you look at these two problems, when we look at the top, we're going to see that the top has a GCF of x. So I'm going to go ahead and take out x. When I look at my leftovers, I'll see x squared minus 6. On the bottom, when I factor that, I'll see a GCF of x. When I look at my leftovers, I'll see x plus 1. Now, once we have all these things in there, for us to be able to reduce the things that are in common, we're going to reduce any GCFs that we have, reduce the things that are in the parentheses if the parentheses are exactly the same. So if you look at this problem, the parentheses are different. So we can't say that those cancel out, but an x on the top and an x on the bottom definitely do. All right, so our final answer here is going to be x squared minus 6 over x plus 1. Now there's a part where it says excluded values. Excluded values for x are kind of like those extraneous solutions we've worked with in the past, and they're values for x that just don't make sense. And the way that we see what our excluded values are is we look at what would make the denominator, the bottom of the fraction, equal 0. Because if you have 0 on the bottom of a fraction, it means you've tried to divide by 0, which you can't do. So on this one, our excluded values are going to be right here. If I have a 0 in for that x right there, it would make the whole bottom of the fraction 0. So 0 is one excluded value. The other excluded value would be right here, -1. -1 plus 1 is 0. So if I had 0 right there, that would make the whole bottom of the fraction equal 0. So the way that you can see what your excluded values are is you can take the pieces, the factored pieces on the bottom of the fraction, set them each equal to 0, and then you'll know. All right, here's for example 2. Step 1 was the numerator over the denominator. That has already happened. Step 2 was make sure they're in descending order. That has already happened. Step 3 is to factor each of these. So if you look at the top, you can see x squared minus 16. Hopefully you recognize that that's the difference of squares. So we have 2 sets of parentheses, one with the plus, one with the minus. The square root of x squared is x. The square root of 16 is 4. So there's the top of our fraction. For the bottom of the fraction, you'll notice that the leading term, or the first term of the bottom, is a negative. And so that means in this part right here, I want to factor out a GCF of -1, and then I'm going to write my leftovers. So if I divide -1 from negative x, that gives me positive x. If I divide negative 1 from positive 4, that gives me negative 4. All right, now here you can see that the x minus 4 and the x minus 4, that set of parentheses are exactly the same, so they cancel out. So for my final answer, I have x plus 4 divided by negative 1. And I don't need to leave that as a fraction because I really can multiply something like that by negative 1 pretty easily. So x divided by negative 1 is negative x, 4 divided by negative 1 is negative 4, and that is my final answer. Now for my excluded values, I just have to look at the bottom of the fraction and see what would make it equal 0. So I'm going to look, I'll do it in purple, I'm going to look at this piece right here. The number that would make that equal 0 is 4, because 4 minus 4 is 0. So I'm going to say my excluded value for x here is 4. I can plug in anything else, it's just that 4 would not work. All right, here's example 3. Step 1, make sure the numerator is on the top, denominator is on the bottom. That part's all set. Step 2, make sure that the problem is written in descending order. If you look at the top, it's written in the wrong order, so we're just going to go ahead and fix that. The bottom is fine just the way it is. All right, step 3 is to factor the top and the bottom. And if you look at this, hopefully you recognize there's a diamond problem on the top and a diamond on the bottom. So for the top, we're multiplying to negative 5, adding to negative 4. Those two numbers would be negative 5 and positive 1. So on the top, I have x minus 5, x plus 1. On the bottom, I'm multiplying to negative 15 and adding to negative 2. The two numbers there would be negative 5 and positive 3. So on the bottom we have x minus 5, x plus 3. So if you can see, the x minus 5 and the x minus 5 cancel because they're exactly the same. So our final answer for this one would be x plus 1 divided by x plus 3. And it's real tempting for students to say, oh, can I cancel out x with x? And the reason you can't cancel those is because x is being added to 1. There's a plus sign. X is being added to 3. There's a plus sign. Well, in between here, you've got a division sign. So if you try to cancel those x's, you're trying to say that plus and divide are opposites of each other, that they undo each other. And I think we all know that's not true. The reason that it works when you have the sets of parentheses is because our two sets of parentheses are being multiplied together. These two sets of parentheses are being multiplied together. The line between them tells us we're dividing something. Dividing and multiplying, those things do cancel out. So that's why it works when you have two sets of parentheses. But if we have something like this with just a plus sign in between, we can't just cancel them. All right, now we want to look at our excluded values. So, oh, here it was. So this is the part we're looking at here, the part I'm circling in purple. So our excluded values are going to be positive 5 and negative 3. Those are the ones where if you plug in the number, it would make the bottom of the fraction equal 0. Now you'll notice every time I looked for excluded values, I didn't look at my final answer. I looked at the problem the very first time that I factored it. I looked at it before I canceled out numbers. So make sure that you do that, because if you looked at the final answer on this one, you could see that an excluded value is negative 3, but you would have missed the 5. So just make sure that you look at your excluded values before you finish the problem. Or at least look at the original problem as opposed to your final answer.